All right, guys, back with another this problem. This is actually just after the previous one, 2022, number 13. You also notice this is another triangle problem, and that's on purpose because a lot of the questions you get will be some form of trig questions, so we want to make sure we remember the identities. So it gives us x, y, z, let us know how to label the points, call it x, call it one, y, call it one, z. We can just decide. And yeah, and it tells us some things that we can go into so we know that. And these sides aren't equal, it's just how I drew the triangle. But yeah, we know that YZ is going to be the length of 8. We know that XY is going to be the length of 10. Upload this. But we're wondering is what the side left side length is going to be, so we're going to that with X. And it also gives us the angle measure of X is going to be 20. Um, so yeah, there's a couple trig identities we can use. I think the easiest one to start off is to figure out the other. I think that if we were to get this angle, it'd be extremely easy to figure out what x could be. So in order to do that, we're going to start off with law of sines. Law of sines, which in case you guys don't remember, is going to be, this case, sine of x, which is going to be 20, divided by the angle across from it, or sorry, the side length across from it, 8, is uh, is equal to the sine of another thing, which is the sine of theta, let's say the side length, divided by x, which is something on the side across from it. So one sec, I'm gonna get the calculator. So yeah, these ones just like law of sines, all the quotes are will really help know because they'll help me solve problems. Some of them will be easier than this. It's just one that I think is worth going over. I'm assuming you guys have already done the math yourselves at this point. Um, so yeah, let's see. Sine of 20. I'm gonna do the math in the calculator, then just start the final answer. Sine of 20 divided by 8. Make sure your calculator is in degrees. Um, I guess I'll write this part out. So it's going to be 0.0427 is equal to sine of theta, which we're going to solve for, over x. And you're like, wait, we don't have enough variables to solve, which I always take a point. But first, we're going to do this as a different uh, sine of, we're going to use law of sines in a different side in this case. We're going to use this one, let's call this angle phi, or angle alpha, I guess. So yeah, Looper can't solve that one first. We're still going to use that equation, just that we can't solve for yet. So sine of phi is going to be equal to 10, and that's also equal to 0.427, which we're going to multiply by 10 and then take the inverse sine of. And here's the key part, is that when you take inverse sine of, if you just plug it straight into a calculator of 0.42, we multiply this number by 10, you're going to get 27. Sorry, 25.31. So like, cool, you could solve the rest of this problem, find out what the other angle is and solve for x. But it does say in the problem that it wants the least possible value of x. And the thing about inverse sine is that there's always going to be two numbers that will give you this value. If you think of a unit circle, which let me just pull up real quick, circle, you can see that if you take the inverse sine of any value, like if you take the inverse sine here, compared to inverse sine here, the y value is going to be the same. So there's going to be two possible angle measures that will give you the same answer for inverse sine. Or sorry, yeah. So for example, if I were to do sine of 25.31, I'm going to get that 0.425. Well, there's another angle. We know based on the unit circle, there should be another angle in degrees that'll also give us this value. And since we want least, we have to check both side measurements. And the way you figure out, well, what's the other one? It's going to be whatever the inverse sine value gives you, and it's going to be 180 degrees minus, in this case, 25.31, right? Is going to be your other angle. This is a dot here. It's 180 minus 25.31, which in this case is going to be 154. Roughly. Don't round all the way since it does tell us to do in thousands, but for convenience sake, we can put that. And again, the way you check this is by saying that, okay, sine of 154.68 or 0.69 is also going to be equal to the 0.04, sorry, 0.427. So yeah, both of these are going to equal it. So it's like, okay, which angle do we want to use? And this is the part where you have to kind of conceptualize it. So right now we're looking at, let's see, the one angle across from 10, we're looking at theta, and we want to figure out how to get the smallest possible x value. And conceptually, we can think about the fact that x is, we want x, the side length, to be solved. We want this angle, let's angle theta, to also be small. Because you can literally just think about as the smaller the angle is, the smaller the side. For example, this was a right triangle. We'd have to open it up a bit more. Not a right angle. And obviously the side length xz would have to be longer. In reality, with these two angles, it's either going to be acute or, yeah, let me actually just draw the actual obtuse angle that it would be roughly like this. Because remember, this diagram isn't to scale at all, so you could do this with a 150 length, and x would be much, much larger. Sorry, the side length xz would be much, much longer. I probably shouldn't call this x, let's call this side A. This is across from sine theta. Let me just get rid of that real quick. So that's side length A, or also known as the length xz according to the problem. So we're going to want to take the smaller of the two angles here, or sorry, the larger angle here in order to make the larger phi angle to make the theta angle smaller. Because now when we do this, since we know angles of triangles add up to 180, we can do the 154 plus the 20 that was given in the problem, and then take that number and minus it from 180 to get that this angle theta should be 5.3. In the other scenario, if we were to make this angle 25, which would still hold true for the equation, this angle y would be like 134, it could be way too great. That would be the obtuse one, and we don't want the xc to be large. So in this case, we can plug in theta is equal to 5.31. And now we solve for this sine value here is equal to sine of 5 point, that's a really bad 5. Definitely not what I was trying to do. 5.31 divided by some value x, multiply both sides by x, find what sine of 5.1 is, and divide that by the 0.0427. Remember, not round because this is it says to the thousand, so that will not be relevant, and we will get the fact that x is equal to, so now we're rounding to thousands because it's our final answer, 2.165, and that is the side length of, sorry, I renamed it to A, but yeah, the length xc is going to be 2.165.